Next heading, enthalpy changes. Enthalpy changes. Enthalpy is the heat content of the system. During a reaction, what happens to this enthalpy? There are reactants. Can you hear me? Anybody please answer?
Yes,
Yes,
ma'am.
ma'am.
Okay. So, during a reaction, what happens to the enthalpy, heat content? In a reaction, there are reactants, there are products. Reactants have got enthalpy, products have got enthalpy. Suppose reactants heat content is more than products heat content, then the extra energy will be released. Suppose reactants are giving products. Reactants heat contents is more than products heat contents. This has got less enthalpy, this has got more enthalpy. That means the rest enthalpy will be released. Or enthalpy of this reaction can be written as enthalpy of products minus enthalpy of reactants. Enthalpy of products, that is delta R, R stands for reaction H, is equal to enthalpy of products. Enthalpy of product, I'll write like this, molar enthalpy in terms of molar enthalpy. Enthalpy of products. You write sigma so that you can add all the products if there are more than one, minus enthalpy of reactants. So this is less, this is more. What I said, the case what I said, this is less, this is more. That means it will be having a minus sign. Minus sign means the amount of energy, enthalpy, heat energy is released. Minus shows that it is released. So enthalpy of a reaction is equal to enthalpy of products, total enthalpy of products minus total enthalpy of reactants. Write down one example, that is CH4. CH4 gas plus 2O2 gas gives CO2 gas, 2H2O liquid. Now you know that this is combustion reaction. During a combustion reaction, heat is liberated, heat is released. See, combustion reaction, combustion of hydrocarbons to give carbon dioxide and water. What is the enthalpy of this reaction? During this reaction or after this reaction, energy is released or energy is absorbed. It is a combustion reaction. Of course, energy is released. You know that we are doing combustion reaction daily in our kitchen. We are burning our hydrocarbon. What our gas from the gas cylinder. We are burning and we are getting the heat. Lots and lots of heat is liberated. Using that heat, we are cooking. So enthalpy of combustion, that is the heat is liberated. So enthalpy of this reaction, if I write butane here, that is a reaction taking place daily in our kitchen. So here delta RH is equal to enthalpy of this plus enthalpy of this minus enthalpy of these two things. So for that we'll be writing HM of CO2, molar enthalpy of CO2 plus twice into HM of water minus of HM of CH4 plus twice HM of CO2 of O2. So this is the enthalpy of this reaction. During this reaction, heat is released. So for this, if you calculate, you will be getting a minus sign if it is a combustion reaction. In some cases, that is an exothermic reaction. In exothermic reaction, you will be getting a minus sign for the answer. For endothermic reaction, you will be getting a plus sign for the answer. Plus means heat is absorbed, minus means heat is released. Next, we are going to delta H for phase transformation. delta H for phase transformation. What is meant by phase transformation? Phase transformation. PHASE. Ice changes to liquid water. Phase transformation. Liquid water changes to water vapor. Phase transformation. Solid directly changes to vapor. That is sublimation. Phase transformation. Vapor changes to solid. Phase transformation. So these things are called phase transformation. So we'll be learning the phase transformation, enthalpy of phase transformation. When the ice changes to liquid water, will the heat absorbed or released? When the water changes to water vapor, liquid water changes to water vapor, will the heat absorbed or released? This way. Ice changes to liquid water. Of course, we know heat is to be absorbed. It will be absorbing heat and ice will be changing into liquid water. Water changes to water vapor. Again, heat will be absorbed. But in which case more heat is required? To convert ice into liquid water or to convert liquid water into water vapor? Of course, liquid water into water vapor. So heat absorbed for the ice to change to liquid water, that is less. Only 6 kilojoules per mole. Per mole means 18 gram ice. Per mole means 18 gram ice को 18 gram पानी बनाने के लिए same amount of पानी, not extra coming. 18 gram ice, if you melt, you'll be getting 18 gram water. That means 1 mole of ice you are melting to form 1 mole of water. How much heat energy is required? 6 kilojoules per mole. So, number 1, that is enthalpy of fusion. Enthalpy of fusion. Right on. It is the enthalpy change. It is the enthalpy change that accompanies, maybe absorbed, maybe released. That it is the enthalpy change that accompanies the melting of 1 mole of a solid. 1 mole of a solid in standard state. In standard state is called standard enthalpy of fusion. Is called standard enthalpy of fusion. Standard state. What is standard state? Standard state means a particular temperature and 1 bar pressure. Standard state means you are fixing the temperature and the pressure. Fixing the temperature means at a particular temperature. When ice melts to water, the temperature is always 0 degree. So here, specified temperature means 0 degree and 1 bar pressure. So standard state means a fixed temperature, a specified temperature. That is, in this particular case, it is 0 degree. 0 degree ice changes to 0 degree water. 0 degree ice changes to 0 degree water at 1 bar pressure. So we are writing the example H2O solid, that is ice changes to H2O liquid, that is liquid water. Delta H, positive or negative? Absorbed, positive. Very less, 6 kilojoules per mole. 6 kilojoules per mole. Now, next heading, enthalpy of vaporization. Now we have liquid water, 18 gram liquid water in our hand, 1 mole. Enthalpy of vaporization, number 2. Enthalpy of vaporization. Now we have 18 gram water, liquid water in our hand. We are going to boil it and convert that all water into water vapor. That means 18 gram water vapor, 1 mole water vapor. What is the amount of energy required? Of course, heat is required. Delta H will be having a positive value. So the previous was delta FH, you can write because fusion, fuse. This is melting. Fusion means melting. Fuse wire, no, that is used for melting that wire when the high current flows, so that this entire circuit will be saved. Here, enthalpy of vaporization will be taking that 1 mole of water, that is H2O liquid, changes to H2O vapor. Delta vape, I'll write delta vape H is equal to plus 40.6 kilojoules per mole. That is, to convert 1 mole of liquid water into 1 mole of water vapor, heat is absorbed. How much heat is absorbed? 40.6 kilojoules per mole. Next, enthalpy of sublimation. Sublimes. You know that camphor sublimes, then what? Naphthalene sublimes, then what? What all things are sublimable? Ammonium chloride sublimes. These are means from directly from solid state to vapor state, gaseous state. Directly from solid state to gaseous state. That is called sublimation. Sublimation. You can say solid carbon dioxide, dry ice, sublimes to carbon dioxide vapor. So again here heat is absorbed. Heat is absorbed. So next C, that is number 3, enthalpy of sublimation. Enthalpy of sublimation. That is, for example, solid carbon dioxide changes to carbon dioxide gas. 25.2 kilojoules per mole is required for this. So delta H sub stands for sublimation. Delta H sub, these all are in standard condition. Standard condition means specified temperature and 1 bar pressure. To show that we can put this standard sign means one line, that is encircled. So this is 25.2 kilojoules per mole. So delta fuse H standard, particular temperature and 1 bar pressure. Delta vape H standard, particular temperature, that means 100 degrees Celsius, 1 bar pressure. Delta sub H standard, particular temperature, specified temperature and 1 bar pressure. The amount of energy absorbed here is 25.2 kilojoules per mole. Next is standard enthalpy of formation. So phase transformation. We are dealing with a different enthalpy changes. What all transformation, what all things, what all processes. Inka enthalpy change. Next is enthalpy of formation. What is meant by formation? A compound is formed from elements. During this process, what is the enthalpy change? During this process, what is the enthalpy change? So enthalpy of formation. For example, you are making a normal compound, famous compound water. its most stable state. That is water in the liquid format. Water in the most stable state. Water means whenever you hear water, liquid state only comes to our mind. Then only it comes, okay, ice, then water vapor. The most stable state is liquid format. When 1 mole of this is formed from its constituent elements, what are the constituent elements? Hydrogen and oxygen. That is 1 mole, here it should be 1 from its constituent elements. So H2, this H2 should be in its most stable state. That is also called reference state. That is also called reference state. मितुल जैन ऐसा कोई है क्या क्लास में? मितुल जैन 11th में है क्या? Anybody please respond. मितुल जैन. Yes, thank you. Thank you, Mukti. Yes, 1 mole of H2 liquid is made from its constituent element, that is hydrogen and oxygen. Only 1 mole is to be made. So accordingly, you adjust the number of moles here. Accordingly, you adjust. That is 1. Here, oxygen should be there, but only 1 O. Oxygen is O2. In their most stable state means oxygen format. Most stable state. From their most stable state, that is oxygen should be in gaseous state, O2, molecular state. Only 1 O is there, so half. I should arrange accordingly, half. So this 2 and 2 get cancelled and you will be getting here 1. So this is what? Half O2. So write down enthalpy or formation. It is the enthalpy change. It is the enthalpy change for the formation of. It is the enthalpy change for the formation of 1 mole of a compound. 1 mole of a compound from its constituent elements from its constituent elements in their most stable state. In their most stable state. At 25 degrees Celsius and 1 bar pressure. At 25 degrees Celsius. 25 degrees Celsius means room temperature. Room temperature means internationally, most of the countries, room temperature means 25 degrees Celsius. At 25 degrees Celsius and 1 bar pressure. Okay. So here what I have taken is water, 1 mole. 1 mole of water. 1 mole of water is formed from 1 mole of H2 and half moles of O2. In thermochemical equation, don't take it as 1 molecule. It is always 1 mole, a mole. In thermodynamics, don't consider them as molecule. Always in terms of moles. So 1 mole of H2 formed from its constituent elements in their most stable state. During this reaction, what is the enthalpy change? During this reaction, what is the enthalpy change? That is the enthalpy of formation of water. That is the enthalpy of formation of water. So here, delta, we are writing F stands for formation. Delta F stand there. What is the specific temperature? 25 degrees Celsius and 1 bar pressure is equal to minus 285.5 kilojoules per mole. There always it is kilojoules per mole. we write like that only, kilojoules per mole. Though here it is 2 or 3 or 4, we always write kilojoules per mole. We don't write kilojoules per 2 moles, or kilojoules per 3 moles. We always write kilojoules per mole. So this much heat is released. Minus sign shows that this much heat is released. Enthalpy of formation of this water, this compound, means from its constituent elements. Condition is there, it should be from their constituent elements and for 1 mole. These are the two conditions, main two conditions, from constituent elements and 1 mole in their most stable state at 25 degrees Celsius and 1 bar pressure. Now, I'm going to one example and you see whether it is delta FH standard. Is it the formation value? CaO solid plus CO2 gas gives CaCO3 solid. Here, delta H is equal to some value I am giving, that is minus 178 kilojoules per mole. Can I write F here? That is the question. Is it the formation value? My question is it the formation value? Can I write F here? No. Why? Because it is not formed from CaCO3. Of course, this is one only, but it is not formed from constituent elements. Elements से नहीं बना है, compound से बना है. So I cannot write F here. So I can write generally a reaction. It's only a reaction. It is not a formation reaction. Another example I am giving. Again, my question is same. Whether it is the enthalpy of formation of the thing, that is H2 N2 plus 3H2 gives 2NH3. 2NH3. Okay, delta H is equal to minus 72 kilojoules per mole, 72.8 kilojoules per mole. Value is minus 92 kilojoules per mole. 92 kilojoules. My question is, can I write F here? No, I cannot write F because this is for not 1 mole, this is for 2 moles. The 2 moles ke liye, that means I cannot write formation here. For formation, there should be 1 like this. Formation, there should be 1. Of course, they are formed from their constituent elements, but this is not for 1 mole, this is for 2 moles. 2 moles. So I cannot write F there. So it's a general thing, that is a reaction. It's not a formation reaction. It is general, that is a reaction. Some simple reaction, not a formation one. Not a formation one. So what is F? What is the F value? Divided by 2. For making 2 moles, this much heat energy is released. Don't look at that portion. This is a general format. Don't look at that portion. So for 1 mole divided by 2. For 1 mole, that is divided by 2. That is the enthalpy of formation. Enthalpy of formation, no doubt. And formation value. Delta FH standard of an element is taken as 0. Delta FH standard of an element. Delta FH standard of an element is taken as 0. 0. Write down in thermochemical equations, coefficient refers to number of moles, not molecules. Not molecules. Not molecules. These 2 points you have to keep in mind while solving numericals. Thank you.